Hello everyone, I'm Van, an application engineer at 3DTC, a CADCAM training center in Vietnam. And for today's class, I'll guide you through some basic tools, what you can do with NX motions, some important things to notice, and how to do a simple simulation using NX. So let's begin. So here is our design. Um, so how this thing works is basically this fan here will spin here leads to the spinning of this bar, which also leads to this bar moving up and down, and it creates a movement for this piston right here. Um, here, here, so it will create a piston moving here. Okay, so the purpose of this class is to guide you through some tools, some important things that you can do with NX motion, all the groups of tools that you want to use, and also do some simulation regarding this design. So let's do it. So the first thing that you have to move to the motion environment. So it is actually in the simulation group. You choose motion, and it will create a new environment for you, um, like here. So basically create a whole new file. So after that you click simulation to light up all the tools that you want to use. Here, create like a name file folder, and then click OK to create a new file for the simulation only. So what is cool about NX is that when you change anything about the project here, like the base file, it will also change in the motion simulation file, as well as the many other tools that you want to use here. So it will change everything, and they all correlate to each other. So it comes in very handy. So the first thing that I want to talk about here is the groups of tools. The first group is a mechanism, which is very important. The mechanism group, of course, is used to create mechanism between the bodies together. So it basically create like how thing going to move. It doesn't create like a simulation, but it defines all the parts here. Like for example, this thing here, it may be a body in the modeling application, but in this motion, it doesn't play a role right now. You have to create a motion body for them. This is a newer version of NX, so it's a motion body for this tool, but it's actually a link tool in the older version. So you should notice that if you are using like the NX 9, 11, or 12 or something. So these tools here helps you to connect the bodies together, as well as yeah, create like you have to create a profile for them. You have to create like an identity for them so that they can move, and you can choose how to like do the animation for them in the motion. So the next tools is the joint. These are the most important tools that I think in this motion application. The joint is actually create. So after you like create the bodies for them, you have to connect the bodies to other bodies. So if you choose you use using joint, you can create like a revolute joint. So this thing will can spin, not spin, and the piston can go up and down as you want, and this thing is spin as you want. So that's how important things is. So this thing connects bodies together, and this thing connect the the motion bodies together to create the motion. This tools comes in. It actually a part of a joint. This driver is actually used to move the joint. Like normally, if you have the joints already, it will not moving. It will just a joint that you can move around, but you cannot move. You have to insert a driver for them so they can move. The next two tools are marker and sensor. The marker is actually just marking point, but it comes in very handy sometimes. For example, if you want the piston to stop moving right when it reaches the 5 centimeters distance from the top here, you can choose a marker, mark this point, distance here, along the x-axis, no, z-axis, and then you choose a sensor. Like the sensor will say, like, right, it z equal 5 centimeters or something, it will stop moving, animation stop. So that's how things work. The function here, it can be used to create like a driver. Like you have the function for the velocity and acceleration, also for the force and stuff later on. So that's a mechanism group. Is a very important thing. These two are the most important one. So yeah, the next group is a coupler. Um, it basically it create like a connection between the movement. It said gear coupler, but it is the fancy words for two revolute joints coupler. So these tools can use to connect two revolute joints, like how they're going to spin. If they spin in the same radio or like in the same speed, you can do that. You can like insert the radio for them. Um, it comes in very handy. You can do like a spinning and sliding joint together to make a record band, and so on. It's a very important joint that you can do to like change the radio of the motion of the speed and stuff. This thing connector is basically connecting the parts together with spring maybe or damper and many other things. You can create a spring and then you have insert like the number for the spring, like the constant for them, and it will works like just like in real life. And that is what simulation do. It simulates things that like as close to real as possible. And 3D contact helps that as well. The contact in the contact group. The 3D contact is very easy to use. You just choose two bodies together and create a contact for them. The 3D contact means that, for example, if you don't have anything here and you just choose simulation, this thing will fall off from this part like immediately. It will go like through them. But if you have a 3D contact, they basically hold them together, like they create a concept for them, basically. So this is constraint, create a constraint. So, for example, if you have a line here and you want this part only spinning around that line, you can do that. Like you can force it to move along the line as well. Some mechanism group, it basically has support for the mechanism group, and those I think are the most important area that you want to do. The things that you want to focus right now, these are not as important as these part right now. With all of those tools, you can do basically whatever you want with the simulation and all the machine and things that you want to do right now. So that is for the heads up on the index motion. So now let's do the simulation for this thing. So as you can see, this thing will spin along with this bar here, create like a motion for this, and then it will spin this bar, and then it will move the piston up and down, as you can see here. Oh, it's a bit laggy, sorry. As you can see here. Okay, so let's do that. So the first thing, as I said before, the first thing that you want to do every time you start motion simulation is to create a body for them. So as you can see, while all the other things are moving, these three parts are actually stay still. So yeah, you can use to define the mass and the inertia for them, but in this version it doesn't really matter. You can just automatically assert it, so it will be much easier. Because those things are not moving at all, you should choose a fixed motion body without joint. So basically fix this body into the environment. So it would not move at all. It would just stay there. Okay. There will always be one fixed motion body in the environment, and you should choose that because it's not hard to see. So okay, so apply. That is the first part, and it will appear like a motion bodies here. If the other version, it will be a link. I said that before. So the next part is that this thing will spin along with this bar right here. So choose that. We don't need the fix anymore. It will spin it, so we don't have to fix it. Apply. And it's the same thing with other here. Sorry. Let's hide that first. So here, and then you create a motion body. Or because those things are like moving along with each other. They stay still compared to each other. So you just choose them to connect them. That's what this is for. And one thing you notice is that even though you don't, this piston here, don't even like moving along with, like stay still with any other things. You still have to choose it because you have to create a profile for them, so that the ID for them, in order to create like a join and many other things after that. So you have to do this thing as well. Again. So that's it basically for the first step. So the next part is to create a joint for them. So after you have like motion bodies, it's not like a body is for drawing. It's like a body for moving, So you connect them to each other. So you just joint. There's like a fixed joint here, but we have already fixed the motion. Fix the motion bodies in the environment, so you don't really have to use a fixed joint anymore. So let's start with this revolute joint here. So we choose the revolute joint. It's basically spinning. So for the revolute joint, there's actually the NX use the origin and vector to define how things going to spin. And because it's spinning like this, you have to choose the origin. Yeah, you have the multiple option for choosing origin. I would just go with the circle center. And the vector, it should be perpendicular to this here. So it will spin using like the point and the vector, so it basically moving this way. The base, you would choose like the fixed one here. So you can change the limits of it, enable and change it, but there isn't really like a limit here, so you don't actually need that part. Yep, you can change the name, but for me, I won't. So basically that's it. Apply, and it will create like a joint here. So that is the first part, and the next few parts are basically the same. You choose this thing are spinning compared to this small hand here, so you choose that part. You choose this part next. For me personally, I would like to choose all the moving parts. Choose the action body and the base body first, and then choose your origin, because I think that makes more sense to me. But you guys can choose whatever, as long as it chooses correct. Okay, so that's the vector like you want, and then don't really have a limit here. Click apply, and next. Like that, you create like a revolute joint between this and this small thing here. So choose that as an action body. That is like a base body. The origin is actually in the middle of this because it's spinning around this hand. So you have to choose that. And then that's vector. Okay, so that's for the revolute. Okay, so the next thing you notice is that this piston is actually moving up and down compared to this. So you have to do like a slider joint for it. This is like the moving. This is the base. And then you choose the origin for it. It's moving up and down, so you should choose like here. We'll move along the vector. Okay. there's like multiple way of choosing and how they choose it. But NX, like I said before, it use origin and vector as a way to define how things are going to spin and moving as well. So yeah, that is the things that you should practice to to know how to choose them. And there will be like a symbol to help you. For example, if you this thing spinning around that, you have like a symbol here, 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 and that, and slide you as well. Okay, like that. Yeah, see that? Okay. Let's show that. That basically everything. But if I choose to create an animation here, things not going to work because we don't really have a driver. Even though those things car can move compared to each other, there's nothing actually like move them. For example, if you have a car, the wheels actually can move compared to the car itself, but you don't have like you didn't run it, so you not spin as you want. So now you have to choose a driver. I would choose this one as a driver. So you can choose a fiction as you want, but no, we don't actually need that. So for rotation, you have a bunch of options for function. You have the polynomial, basically velocity, acceleration, and many other things. You have the harmonic function. It will like running up and down like that. And then there are many other things that you can choose, but in this simulation, I would just go with a fixed velocity. Okay, and after that, there will be like a red um, arrow, which shows that it is like a driver joint for the whole simulation. So after that, you just choose basically done with the simulation. We choose a solution. Um, in this solution, we can choose how things going to like show. So I would use a fixed number of steps for this simulation. Um, in the older version, there will be steps instead of like time and stuff. So used to that. Let's say 5 seconds and 250. Um, so there's a bunch of options. And also you have the option to change the gravity itself, and also um, choose the direction of gravity. In this simulation, it is this way, which is correct if you want to change it, or if you want to do a simulation on Mars or something, you have to like change the gravity itself. But for now, it is good to me. Okay, so click OK, and then you have a solution here. Solve it. Okay, and after you solve it, there will be a line said redundant constraint you will remove automatically whenever something. You don't really have to care about that line very much. It doesn't really matter because that like always appear as long as you do the simulation. So we don't really care about that. So you have like a graph here. You have the animation here. So let's watch that. Choose an animation player. So there's a bunch of options you can choose to play it, like play once, loop, or retrace. We'll just go with retrace. So you can run for 5 seconds. So yeah, you can see that it's spinning right here. So if you hide that, yeah, it is spinning right now. So those are the basic steps of how things going to move with each other. See, this thing driver, so it's driving the whole thing. And this is like a piston going up and down. Don't really have to put a limit for it because the mechanism has already allows it to move up and down like that. So yeah, those are the things that I want to talk about today. Hope you enjoy it, and if you have a question, you can ask me later. So yeah, that's it. Have a good day.